Thanks to a heightened sense of urgency, scientists around the world are now working towards reaching the next step in vaccine development, the creation of contagious vaccines. Just like what its name suggests, the whole idea behind the effort is to develop new vaccine types that, once administered to a patient or subject, can continue spreading through contact with others, or through reproduction, and end up providing communities with herd immunity much quicker than a disease can. In the past, we've already seen how vaccines containing weakened versions of a virus have proved to be slightly contagious, such as the oral polio vaccine, for instance, which works by having a weakened polio virus replicate itself inside the intestines of a child, before transmitting to other children when in close contact. Some other scientists have also said that contagious vaccines could be instead used within the animal kingdom, where animals that usually carry zoonotic diseases such as bats are given these vaccines, which then combat the diseases before they have an opportunity to reach humans. One team of researchers from the University of Idaho and University of Western Australia said that the current approach to dealing with zoonotic diseases has been largely reactive, as in most viruses are dealt with using a wait-and-see method. They said that this can lead to deadly and costly time lags between emergence and control of such diseases. Image: The Economic Times. Their work now revolves around using mathematical data from previous studies to see whether or not it would be possible to be more proactive, and use transmissible vaccines to neutralize such pathogens within animal populations before they can reach humans. Our models are focused on transmissible vaccines designed using herpes virus vectors and demonstrate that these vaccines, currently under development for several important human pathogens, may have the potential to rapidly control zoonotic pathogens within the reservoir hosts, the team said. Things to be wary of. Of course, many experts have also cautioned against the pitfalls of using such transmissible vaccines, whether it be in the animal kingdom, or among the human population. The first concern deals with vaccine immunity, a scenario in which the vaccine actually evolves as it gets passed around from one organism to another. As the vaccine continues to evolve, it eventually becomes more dissimilar to the virus or pathogen it was designed to fight against, eventually losing its efficacy. This problem could theoretically be solved by simply introducing more vaccines to kickstart the process all over again. The second concern deals with the problem of the transmissible vaccines eventually becoming dangerous to humans rather than protecting them. Use in humans may be warranted for populations that are hard to reach, or for epidemics that are uncontrollable by direct vaccination, said Mark Smithson, who is from the School of Biological Sciences at Washington State University. However, using transmissible vaccines could be dangerous, mainly because vaccines with a potential to spread through a host population also have the potential to revert back to the disease. Curiously enough, something like this has already happened before with the oral polio vaccine. Regarding this example, the World Health Organization, WHO, said that in rare instances, within severely under-immunized populations, any excreted vaccine virus can continue to go around for lengthy periods. And without anything to keep it in check, like stronger antibodies provided by more vaccinations, these vaccine viruses can genetically evolve. In the case of the oral polio vaccine, it managed to evolve so much within one community that it developed the ability to cause paralysis, and became known as a circulating vaccine-derived poliovirus, CVD-PV. This problem, however, can supposedly be avoided by simply ensuring better coverage for all communities taking a vaccine, so that the virus itself will not be allowed to change genetically to the point of becoming something more dangerous or too different to be dealt with by the vaccine. The problem is not with the vaccine itself, but low vaccination coverage, the WHO said. If a population is fully immunized, they will be protected against both vaccine-derived and wild polioviruses. The targets are zoonotic pathogens, for now. At this moment, however, the concerted effort to develop more transmissible vaccines will be focused on the animal kingdom, more specifically to provide herd immunity among animal groups that carry zoonotic diseases. There has so far been one experiment in this area of research, where 147 wild rabbits were captured by researchers, and then half of them vaccinated against rabbit hemorrhagic disease and myxomatosis, another disease commonly known to afflict rabbits. After getting vaxxed, all the rabbits were then microchipped and released back into the wild, half of them now carrying the vaccine virus similar in nature to the original myxomatosis virus. After 32 days, the research team found that the vaccine virus had been able to spread, with 56% of unvaccinated wild rabbits now carrying antibodies resistant against both diseases, indicating some degree of success. While this has been the only real-world proof of success so far, a mathematical model has shown that such a technique could prove to be a game-changer if done right. Scientists are now working on using transmissible vaccines to tackle Lassa virus, which is heavily present in rats. Image. Science News. The model developed by scientists from the University of Idaho and University of Western Australia showed that transmission rates of the Lassa virus in rats could be reduced by a whopping 95% within 3 years, should the technique be successful. Currently, aside from Lassa virus, other teams around the world are also working on other transmissible vaccines for zoonotic diseases, including Ebola and bovine tuberculosis. And while it's all still very experimental right now, these developments could very well mean that we may be far better equipped to deal with another rampant virus whenever it rolls around in the future, or maybe even not at all if these vaccines end up proving super efficient. Read more life stories. People who still haven't had COVID-19 have no friends, Korean doctor says. Thai trans model turned away at Dubai airport for possessing male passport. Sporians can soon go maskless outdoors as country relaxes COVID-19 restrictions. Cover image sourced from BBC and Mayo Clinic.